Angela Harris with the ACHR News, and I'm here at the UA Green Training Trailer. We're going to take a quick tour and see who we can find on board and what they're learning.
They're in little strips, they glue down, and with that we're pulling power from the sun's energy, bringing it down here, putting it into the batteries. We store it here, we go through the inverter. All of the 110 volt power that's required for this trailer is actually provided from the photovoltaic. We've got a 25 kW generator running out there, but that's to pick up the larger amperage that's required to run the other trainers. Well, the heat transfer fluid that we're using is a DuPont product called Cestera. It's environmentally friendly. From what I'm told, it's made from corn-based products instead of your normal petrochemical products. There's no glycol in the system. Moving along here, we've got the water source heat pump. Some people call it geothermal. I guess the proper name for it would be a water source heat pump. And the way the trailer is set up is someone could walk through here, and without having me explain to them what it all is, they could actually go through here and read the pictorials and the words that we have up there. It's written in simple language so that they can get a lot out of it. And this display here, we're showing a commercial application and several residential applications of the ground loops that's required to run this system. Next to it, we got a little heat recovery device which can route the heat that's either being rejected or pulled from the earth to other areas of the home to be used in other areas. So it's a little changeover device with the pump installed into it. Normal backflow installation here. Again, we're contained in all our water, but we can actually monitor the use when the flushometers are being flushed or whatever on how many GPM we're actually pushing through these pipes. This is a 200-gallon tank. This is what we're storing all of our hot water in. It's being utilized throughout the trailer for our potable hot water system. Also, the floor is hydronically heated throughout the trailer. We've got a few examples you're going to see up here where you can actually see the piping in the floor. But several heat exchangers are being used inside of here, one of them which is being supplied by the vacuum tube collector. When we go outside, you get a better view of it. The sun's not shining over here, but you can actually see we are still piping heat over from it. When the collector's fully collecting heat, the boiler is usually in standby because it's generating enough heat for our needs. At nighttime, when the sun's not shining, the boiler will actually kick in to pick it up. And in those times when it's not generating full, it's actually serving as a preheater for the boiler so the boiler doesn't have to work so hard. This is the solar collector control system in the pump, all built into one unit. We could set it, it's universal to run on 3 different flow rates. So depending on what our requirements are, we can actually select it. We also have a DDC control system that's monitoring everything. When we get on the display over here, you can actually look at the whole system in one picture. We've got additional sensors in there which feed back to the Johnson Controls DDC system. The direct digital control system also is green because it allows you to run a building more efficiently. The way this system is designed, it's easily installed on a retrofit. It can also be economically put in on an original installation too. The boiler we're using here is a 95% condensing furnace. It's extracting as much heat as it can before it actually leaves. That's why you can do everything in plastic pipe. And it's got to have also a P-trap put into it to actually collect the condensate that's coming off of it to be piped over to the sewer system.